Hello, this is Walter Stone, and this is part 2 of Unit 6, Lesson 5, Solving Equations and Applications using the zero factor property. And so in this second part of the lesson, in terms of a second video, we want to be able to solve application problems. And when we do that, we first translate the problem situation into an equation and then solve the equation. Then we check to see if the solution satisfies the conditions of the original problem. So it's always good to do that. So in this first example, we have the square of a number minus the number is 20, and we want to find the number. So suppose we let x be that number. Then what we want to do is use that variable to write an equation that says the square of a number, x squared, minus that number x is equal to 20. So is equal to, in this case, so we have x squared minus x equal to 20. And this is a quadratic equation. And so what we want to do is make sure we write the equation in standard form, so we can subtract 20 from both sides, factor the equation, and so we have that x minus 5 equals 0 or x plus 4 equals 0. So x is equal to 5 or x is equal to negative 4. And both of these solutions satisfy the original problem. If we take 5 squared minus 5, that gives us 20, because 25 minus 5 is 20. And the opposite of 4 squared minus negative 4, if we have 16 plus 4, that also gives us 20. So the solutions to this problem are 5 and negative 4. Okay, so suppose we want to solve this problem, that the square of a number minus twice the number is 48, and we want to find the number. Okay, so work on this problem, solve first, pause the video, and work on this problem and come back and we can go over the solution. So in this case, we can let x equal to the number, and we're taking the square minus twice the number is 48. So I translated that sentence into the equation. We can subtract 48 from both sides to make sure the equation is in standard form. We can factor the left-hand side. So you can check my factors here. Negative 8 times 6 is negative 48. If I take 6x minus 8x, I do get negative 2x as my middle term. So if x minus 8 is 0, then x would equal 8. And if x plus 6 is 0, then x would be negative 6. So the numbers can be 8 or negative 6 in this case. In our second example, we have that the width of a rectangle is 2 meters less than the length. The area is 15 square meters. So here we have that if L is the length of the rectangle, the width would be L minus 2, because the width is 2 meters less than the length. And we're given the area. So if we want to find the dimensions of the rectangle, we can take length times width to give us the area of 15. So L times L minus 2 is equal to 15. And we can solve that equation. So if I distribute the L, we have L squared minus 2L equal to 15. We can subtract 15 from both sides to make sure we have standard form. And the factors of L squared minus 2L minus 15 are L minus 5 times L plus 3. Okay, so we get negative 15 in the lasts, and 3L minus 5L gives us negative 2L. So we have two equations here we can write with the zero factor property. So either L minus 5 is 0 or L plus 3 is 0. And if we solve this first equation, we get L equal to 5. And if we solve the second equation, we get L equal to negative 3. Now, the length of a rectangle cannot be a negative number. So the only length we can look at here as a possibility is 5. So if the length is 5, 5 minus 2 is 3. So this would be a 5 by 3 rectangle, and 5 times 3 does give us an area of 15. So the length of the rectangle is 5 meters and the width is 3 meters. Okay, so at the bottom of the screen here we have a try this problem, and on your sheet this should be corrected. The width of a rectangle is 5 centimeters less than the length. The area of the rectangle is 24 square centimeters. Find the dimensions of the rectangle. So pause this video, try this problem out, and then come back to look at the solution. So here we have that the width is 5 centimeters less than the length. So I drew that rectangle showing that relationship. And we know that the area of the rectangle is 24 square centimeters. So we can take length times width, L times L minus 5, and that will equal the area of 24. So I want to write this equation in standard form. L squared minus 5L equals 24. And then we can subtract 24 from both sides. So this factors into L minus 8 times L plus 3, so we get negative 24 as our last term. 3L minus 8L is negative 5L, so that checks. So if L minus 8 is 0, that means L is 8. And if L plus 3 is 0, that means L is negative 3. And I got rid of that solution because lengths have to be positive. So if the length is 8, the width is L minus 5, or 8 minus 5, which is 3. So the dimensions would be for length 8 centimeters and for width 3 centimeters. And 8 times 3 is 24 square centimeters. So that checks with our, that solution checks with the original problem, which is what we like to see. Okay, so there's some written practice with solving equations and solving these application type problems. So one thing you want to do is work on those and also work on the online work for this section, and we will see you in class. Take care.